Let me read the question 12 now. Diagram 8 shows a purple colored right angle triangle pattern on a net of a rectangular roll of paper. As you can see, the height of the rectangular roll of paper is actually 12 centimeter. Okay, continue to read the question. It is given that the length of the base of the first triangle is a centimeter and the length of each subsequent base increases by d centimeter. Okay, let me read the question part A. Derive that the length of the base of the nth triangle is t subscript n equals to a plus n minus 1 d. Okay, this is for the part A. Okay, for the question part B, on the net, the 31st purple colored triangle is the last triangle with an area of 72 centimeters square, and it is given that A is equal to 30D. Okay, so within the question B, you have the part 1 where they ask us to find the value of D in centimeter. Okay, continue to read for the part 2. Zol wants to send a number of rolls of the paper to his friend through a courier company. Table 2 shows an information related to parcel delivery charges. Okay, as you can see here, you have table consists of the mass and the rate. Okay, the mass from the range of 0 to 2.5 kg is 9 ringgit, and every subsequent 500 gram after that will be 1 ringgit and 20 cents. Okay, so this is the table 2. Okay, back to the question now. If Zol has 15 ringgit and the mass of the paper per centimeter square is 4 times 10 to the power of negative 5 kg, calculate the maximum number of rolls of the paper that can be sent. Okay, so this is the overall question 12, guys. Okay, I know it's a long question and it can be little difficult, but it is possible for us to solve. Okay, so take your time to solve this question and we will begin the discussion in a count of 5, 4, 3, 2, 1. Let us begin our discussion for the question 12 part A, where we need to derive that the length of the base of the nth triangle is t subscript n equals to a plus n minus 1 d. Okay, this equation is the formula of arithmetic progression to find the value of the nth term, guys. Okay, so from here, as you can see here, we have 3 triangles. Okay, start with the T1, T2 and T3. Okay, as mentioned by the question, okay, the length of the base of the first triangle is a centimeter. Okay, so that's why I've written here a. Okay, and then they also mentioned that the length of each subsequent base increases by d centimeter. So from here, for the second triangle, it will be a plus with d, guys. Okay, the base. Okay, and then for the third triangle, base on the second triangle, it will be subsequently increased by d. So in this case, it will be a plus d, hence it will be a plus with 2d. Okay, so from here, in terms of the length of the base, okay, start with the triangle 1. Okay, so from here, triangle 1, okay, will be equals to a. Okay, so you can write as a, and you can also write in terms of a plus with 0 d. Okay, 0 times with d, you get is 0. Okay, so from here, so this is your length of the base of the triangle 1. Okay, for the second triangle, okay, equals to a plus with d. Okay, of course we don't write as 1d. It is understood that the coefficient d is actually 1. Okay, for the third triangle, the length of the base is actually equals to a plus with 2d. Okay, so from here, take a note the coefficient of d and the number of the terms, guys. Okay, for example, let's say if I take here t2, okay, the term over here is higher than coefficient of the d by 1. Okay, and same things apply over here. Here you have your coefficient, here you have the subscript 3, which is higher than the coefficient d. In this case is 2. Okay, by 1, guys. Okay, so by following this pattern, so from here we can conclude that your nth term, okay, let me use a different pen. Hence, your nth term Tn or T subscript n is equals to A plus with n minus 1 D. Okay, so this is the formula of the arithmetic progression, guys, okay, which in this case it is fulfilling. Okay, let's say if I place a 1 here, T1 will be equals to A plus with 1 minus 1D. 1 minus 1 is 0, so 0D is 0, so that's why you have A. Okay, your first term is known as A. Okay, so from here, let me box this. It just requires a small step of derivation. Okay, so from here we're done with the question part A. Let us move on to the discussion for the question B part 1. Okay, where we need to find the value of D in centimeter. Okay, so from here let us recall the question again. Okay, the question mentioned that on the net the 31st purple colored triangle is the last triangle with an area of 72 centimeters square, and it is given that A is equals to 30D. Okay, so the area of the triangle is 72 centimeters square. That doesn't mean that the length of the base is 72. Okay, some student, what they will do, they will just, the moment they see okay it's 72, they'll just assume it as the length of the base. Okay, here you need to be careful, guys. Okay, they mentioned that on the 31st purple color triangle, the area of the triangle is 72 centimeters square. That's what it means. Okay, so from here let me write in the working that area of 31st triangle is equals to 72 centimeter square. Okay, so from here the first step what we need to do is we need to find the length of the base of the 31st triangle. So how are we going to do that? Very simple. Okay, we're just going to apply the formula half times base times with height. Okay, height is fixed 12 centimeter. We just need to find the base. Okay, so from here 1 over 2 times with 12 and you times with x. Okay, this 12 is indicating the height and this x is indicating the base. Okay, they can be switch their position front and back, guys. Okay, doesn't matter. Okay, so from here half times with base times height or height times base, so you should get equals to 72. Okay, so half times with 12, so you simplify this, you get 1, simplify this, you get 6. So from here 6x is equals to 72, and from here you get your x is equals to 12 centimeter. Okay, so this 12 centimeter is actually the base length of 31st triangle. This x equals to 12 centimeter is actually the base length of 31st triangle, guys. I hope you guys are clear. So from here we can write that T31, okay, the length of the base of the 31st triangle is equals to 12 centimeter. Okay, so from here we're going to apply the arithmetic progression formula. Okay, A plus n minus 1D. Okay, so from here, okay, A plus with, okay, n minus 1. Okay, in this case our nth term is 31, so 31 minus 1, okay, 31 minus 1, okay, times with the common difference D, okay, equals to 12. Okay, once we are done with this step, take a look at the question. They mentioned that expression A is actually equals to 30D. So from here what we're going to do, we're going to replace A as 30D, guys. Okay, so from here, okay, let me write the equation here. So since A is equals to 30d. Okay, in this case 30 times with the common difference. Okay, so we're going to substitute a as 30d. We're going to replace this 30d over here. So from here 30d plus with 30d is equals to 12. Okay, 30d plus 30d is equals to 60d. So 60d is equals to 12. Okay, so to find the common difference, what you do, 12 you divide with 60. So from here you solve this, you should get your common difference d is equals to 1 over 5 centimeter. Okay, if you wish to write your answer in fraction also can, I mean in decimal also can, or you want to wish to leave in the fraction form also can. Okay, so from here you get your d is equals to 1 over 5 centimeter. Okay, so we have done with the question B, part 1. Okay, up until now, I hope you guys are clear. The real challenge starts now, guys. Okay, I'm going to guide you one by one. Okay, so stay with me, guys. Okay, let us begin our discussion for the question B, part 2. So try to solve the information that we already obtained. Okay, so from here we knew that our common difference d is actually equals to 1 over 5 centimeter. So when d is equals to 1 over 5 centimeter, okay, so from here your first term a is actually equals to 30 times with 1 over 5. Okay, you simplify this, you get 1, you simplify this, you get 6. So from here you get your a is equals to 6 centimeter. Okay, what is this indicates, guys? Okay, this means that the base length of first triangle okay, the next step what we're going to do is we're going to find the summation of the length of the base of the triangle. Okay, in this case the 31st triangle is the last triangle, guys. Okay, so from here our step 1 will be find S31. Okay, this will be our very first step, guys. Okay, because the end of question B part 2 we need to calculate the maximum number of rolls of the paper that can be sent. Okay, that one I will come back later, but for now, okay, I want you to break down the question one by one. Okay, so for the first step you find S31. Okay, this S31 is based on the base length of the triangle, guys. Okay, so from here, given that Sn is equals to n over 2 in a bracket 2a plus with n minus 1 close bracket d close square bracket. Okay, so from here S31, okay, which is the summation of the length of the base of the triangle, okay, is equals to 31 over 2 times with 2 times with 6. Okay, 6 is the length of the base length of the first triangle, plus with 30 times with 1 over 5. Okay, so from here you solve this. Okay, you should get S31 is equals to 279 centimeter. Okay, this is the summation of the base length of the triangle, guys. Okay, so we have done our step 1. Okay, let me remind you again, guys. Okay, this is actually a net of a rectangular roll of paper. Okay, a net of rectangular roll of paper. Within the net of rectangular roll of paper, they're forming the purple colored right angle triangle. Okay, so let me just write a reminder. Okay, reminder for you. net of rectangular roll of paper. Okay, which means that, okay, let me draw a rectangle. Okay, so from here your height is 12 centimeter and your length is 279 centimeter, or even accurate, you will say length times its width. Okay, length times its width. Okay, so from here our next step is to calculate the total area of rectangular roll of paper. Okay, in this case we mentioned as A31, guys. Okay, so from here, total area of rectangular roll of paper. Okay, in this case we write it in terms of area, A31. Okay, why 31? Okay, because it forms 31 triangles, guys, within this rectangular. Okay, so from here the total area of rectangular roll of paper A31 is equals to length times with width, in this case 279 times with 12. You should get your answer is 3348 centimeters square. Okay, we are not done yet. Okay, so it's still in the step. Okay, so this is your step 2, by the way. Step 2, find A31. Okay, so from here, once we get the A31, okay, so from here we can now find the total mass for one roll of paper. Okay, how we can find the mass of one roll of paper? They already give us in the question that mass of the paper per centimeter square is 4 times 10 to the power of negative 5 kg. Okay, so from here, step 3, find mass for one roll of paper. Okay, so from here, total mass for one roll of paper is equals to, okay, 3348 centimeter square. This is the total area of the roll of paper, guys. Okay, rectangular roll of paper. Okay, times with 4 times with 10 to the power of negative 5 kg per centimeter square. Okay, so from here you calculate this. Okay, let me take out the calculator. 3348 times with 4 to the power of negative 5. Okay, so from here you get 0.13392 kg. 0.13392 kg. Okay, so from here we have identified the summation of the length of the base, and we have already find the area of the rectangular roll of paper, and we have already find the mass of one roll of paper. Okay, by getting all this information, then only we can proceed to find the maximum number of rolls of the paper that can be sent. Okay, how are we going to do that? Okay, let us recall the budget of Zol. Okay, in this case Zol has 15 ringgit. So in this case Zol's budget is 15 ringgit. Okay, let me make this clear, guys. Zol's budget is equals to 15 ringgit. Okay, in this case we can straight away minus the 9 ringgit rate. Okay, since it is very straightforward. Okay, so from here RM 15 minus with RM 9. Okay, so we can take the highest possibility of this mass. In this case is 2.5 kg. Okay, so from here 15 ringgit minus with 9 ringgit, you only left with 6 ringgit. Okay, so from here, for the next rate, they mentioned that every subsequent 500 gram, it will be increased by 1.2 ringgit. Okay, and you have the balance of 6 ringgit over here within Zol's budget. Okay, so from here, 6 ringgit, you divide with RM 1 ringgit 20 cent. Okay, it will be equals to 5. Okay, that means you need to increase subsequent 500 gram for 5 times. Okay, in this case it will be 5 times with 500 gram, or even better we write in terms of kg, 5 times with 0.5 kg, we multiply them. So from here you get equals to 2.5 kg. Okay, so from here you have 2.5 kg, here you have 2.5 kg, hence maximum allowable mass is equals to 2.5 kg plus with 2.5 kg. Okay, plus them together you should get equals to 5 kg. Okay, I hope you guys are clear until now. Okay, now we are doing breakdown in terms of the Zol's budget. Okay, so we minus with the first 9 ringgit. Okay, the range from 0 up to 2.5 kg, and we have left 6 ringgit, and thus 6 ringgit you divide with the subsequent rate, which is 1.2, which you need to subsequently increase by 5 times. So 5 times with 0.5 kg, you get 2.5 kg. So you add these two mass together, you get the maximum allowable mass of 5 kg. So I hope you guys are clear about this. So once you identify the maximum allowable mass, so now we need to calculate the number of paper rolls under 9 ringgit. Okay, so from here, number of paper rolls under 9 ringgit. Okay, so how are you going to calculate? Okay, remember guys, under 9 ringgit, your allowable mass is 2.5 kg maximum. So 2.5 kg. Okay, and then you divide with mass of one rectangular roll of paper. So the mass of one rectangular roll of paper is 0.13392 kg. You should get approximately, so let me calculate. So 2.5 divide with 0.13392, you get 18.667, and in a decimal. But of course, when you're having rolls, you cannot expect to have 18.66 rolls, 18.7 rolls, anything in decimal. You must have a whole number. So in order to have a whole number, you need to choose the smallest value, guys. In this case is 18. Okay, so approximately you have 18 rolls. Okay, so we have already done with the number of paper rolls under 9 ringgit. Now we focus the number of paper rolls under 6 ringgit. Okay, number of paper rolls under 6 ringgit. Okay, the number of paper rolls under 6 ringgit is very simple. Okay, you divide with the mass of 2.5 kg. Okay, divide with the mass of one rectangular roll of paper, which in this case is 0.13392 kg. Okay, you get the same, approximately 18 rolls. Okay, so from here 18 rolls plus with 18 rolls, you get equals to 36 rolls. Okay, and remember that the mass of one roll is actually 0.13392. Okay, to check whether we have already attained the maximum allowable mass, okay, so let us calculate now. So 36 rolls times with 0.13392 kg, okay, is equals to 4.8211 kg. Okay, in this case, okay, so from here 5 you minus with 5 minus with 4.8211. okay, let me show you over here. 5 minus 4.8211, you get 0.1789. okay, the mass of one rectangular roll of paper is 0.13392, which means that we can add one more roll, guys. Okay, so from here 5 kg minus with 4.8211 kg is equals to 0.1789 kg. Okay, this means that we can add one more roll. Okay, add one more roll. Okay, let me clarify to you that adding this one more roll is not going to affect Zol's budget, guys. Okay, so from here we are almost into our final working. Maximum roll of paper, okay, R max is equals to 36 plus with 1. So from here you get your maximum roll of paper that can be sent is equals to 37 rolls. Okay, I hope you find this video useful. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.